The weight of each apple harvested from a particular orchard determines where the apple will be sent. If the weights of the apples are normally distributed, and the weight is more than 250 grams, it goes to the premium outlet, between 150 and 250 grams to the normal market, and less than 150 goes to the juicing factory. Of 1,000, 23% are sent for juicing, and 40 are sent to the premium outlet. So that 40 there is going to be 40 out of 1,000, which is 4%. Find the mean and standard deviation of the weights to the nearest gram. So once again we have an unknown mean and an unknown standard deviation, so we're going to have to standardize and use simultaneous equations. Now let's just sketch what we're being told. So 23% are sent for juicing. Now because the normal is symmetrical, we know that the mean splits it into 50% and 50%. So 23% is going to be down here. So we don't know the mean, but we know that 23% is sent for juicing, and that's if the weight is less than 150. So if this is 150, that's down there. So if we have our distribution as being x is a normal mu sigma squared, then the probability of x being less than 150 we know is 0.23. For the premium outlet, 4% and above is up here. That's going to be 250. We know this is 4% in here. So the probability of x being more than 250 is 0.04. So what we want to do is standardize these. So the probability of z being less than 150 take away the mean divided by the standard deviation is 0.23, and the probability that z is more than 250 take away the mean divided by the standard deviation is 0.04. So we know probabilities, we can work out these two things by using the inverse normal. Let's just drag the calculator over here so we can see what we've got here. So we want the inverse normal CDF, and for the first one being a less than, we want the left tail 0.23, and we're using standard because we've standardized, so that's negative 0.7388. So we can say 150 take away mu over sigma is the value that we just found, negative 0.7388. And over here we have 250 take away mu over sigma, and for this one we're going to want a right hand tail because we know that's a greater than, so that's down the right, and the probability is 0.04, 4%. Make sure we've got the right value in there, and that gives me 1.7507. So I could rewrite this one as 150 take away mu is negative 0.73. I think that was 88. I can't remember my own writing, so let's just go back. Yes, it's 88 sigma, and here we've got 250 take away mu is 1.7507 sigma, and we just want to solve these simultaneous equations. Let's call them 1 and 2. So we can use the simultaneous equation solver, and that's 150 take away x is equal to negative 0.7388. That's sigma. And then here we've got 250 take away mu, which I've called x, is 1.7507 mu, and we're solving here for x and y, and execute. So that gives us the mean was 179 point something. Let's go back and get that. Should we say 68? And the standard deviation was 40.17. And we're now in a position to do the rest of exercise 7F.